If you've ever looked up at the night sky and wondered whether we're alone, you're not the first. But here's the thing. The more scientists search for signs of intelligent life out there, the more disturbing the silence becomes. We're talking about 400 billion stars in our galaxy alone. Planets everywhere. Conditions for life scattered across the cosmos like seeds in fertile soil. By every calculation, every statistical model, every reasonable estimate, the universe should be teeming with civilizations far more advanced than our own. And yet, nothing. No signals, no probes, no megastructures blocking starlight, no evidence whatsoever that anyone else is out there, just silence. Cold, absolute, inexplicable silence. This is the Fermi Paradox, and trust me, once you understand what it really implies, you'll never look at the stars the same way again. In 1961, astronomer Dr. Frank Drake sat down with a piece of paper and created what would become known as the Drake equation. It was an attempt to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. Drake wasn't some fringe theorist. He was a respected scientist at Cornell University, working with the most sophisticated radio telescope equipment of his era. His equation took into account the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and so on. When he ran the numbers, even with conservative estimates, the result was staggering. There should be somewhere between 1,000 and 100 million civilizations in our galaxy capable of communicating with us right now. 100 million? And that's just our galaxy. There are over 2 trillion galaxies in the observable universe. The numbers become so large, they lose meaning. So Dr. Drake and his colleagues at the newly formed SETI Institute pointed their radio telescopes at the sky. They listened, they analyzed, they waited. What they heard was nothing. Not interference, not scrambled signals, nothing. The cosmic equivalent of dialing a phone number and having it ring forever with no answer. But here's where it gets truly unsettling. The physicist Enrico Fermi, over lunch at Los Alamos National Laboratory in 1950, asked a simple question that has haunted scientists ever since. If intelligent life is so probable, if the universe has had 13.8 billion years to produce advanced civilizations, then where is everybody? The question sounds almost childlike, but the implications are anything but. You see, our galaxy is roughly 13 billion years old. Our solar system is only 4.5 billion. That means there was plenty of time, over 8 billion years, for other civilizations to arise, develop technology, and spread across the stars before our planet even existed. Even using the slowest forms of space travel we can imagine, a civilization that arose just 1 million years before us could have colonized the entire galaxy by now. 1 million years sounds like a long time, but in cosmic terms, it's nothing. A rounding error, a blink of the eye. So where are the colonizers? Where are the probes? Where are the signals? Dr. Jill Tarter, former director of the SETI Institute, spent over 30 years listening for extraterrestrial signals. She pointed dishes at thousands of star systems. She analyzed petabytes of data. She found patterns in noise and noise in patterns. What she never found was a single confirmed signal from another civilization. The silence, she said in a 2019 interview, is becoming harder to explain away. And she's right. Because as our technology improves, as we discover more Earth-like planets, as we understand more about the conditions necessary for life, the silence becomes more deafening, not less. In 2017, astronomers detected an object passing through our solar system that behaved unlike anything they'd ever seen. They named it Oumuamua, Hawaiian for scout. It was cigar-shaped, tumbling end over end, and it accelerated away from the sun in a way that couldn't be explained by gravity alone. Dr. Avi Loeb, chairman of Harvard's astronomy department, published a paper suggesting Oumuamua might be an alien probe or a piece of debris from an alien technology. The scientific community largely dismissed his claims, but they couldn't explain the acceleration either. Oumuamua passed through our solar system and disappeared into the void. We'll never know what it really was. But here's the disturbing part. If advanced civilizations exist, They should have sent probes everywhere. Self-replicating machines that could explore the galaxy in a few million years. We should be swimming in them. Instead, we got one weird object that we couldn't explain. And then, nothing. The scientists trying to solve the Fermi Paradox have proposed dozens of explanations over the years. Some are reassuring, most are not. The first category suggests that perhaps intelligent life is simply rarer than we thought. Maybe the conditions for complex life are so specific, so dependent on a perfect chain of unlikely events that we're genuinely alone. Or nearly alone. This is called the rare earth hypothesis. It argues that while simple microbial life might be common, the jump to complex multicellular organisms, and then to intelligence, requires such specific conditions that it almost never happens. Dr. Peter Ward, a paleontologist at the University of Washington, co-authored the book that popularized this theory. He points to mass extinctions, planetary impacts, and cosmic radiation as filters that prevent most life from evolving intelligence. We might be the cosmic lottery winners, he said, and lottery winners are rare by definition. But here's the problem with that explanation. Even if intelligent life is incredibly rare, even if only 1 in a billion stars produces a technological civilization, that still leaves thousands of civilizations in our galaxy alone. The numbers are just too big. So maybe the problem isn't that intelligent life is rare. Maybe the problem is that intelligent life doesn't survive. This brings us to the Great Filter theory. And trust me, this is where things get dark. The Great Filter is a proposed barrier, somewhere in the development of life, that is extremely difficult to pass. Something that kills off almost every civilization before it can spread to the stars. The question is whether the filter is behind us or ahead of us. If the filter is behind us, that's actually good news. It means the hard part, whatever it was, happened in our past. Maybe it was the jump from single-celled to multicellular life. Maybe it was the development of intelligence itself. Whatever it was, we passed it. We're the lucky ones. But if the filter is ahead of us, that means something terrible awaits every civilization that reaches our level of technology. Something that wipes them out before they can colonize the galaxy. Dr. Robin Hanson, an economist at George Mason University, first proposed the Great Filter in 1998. His analysis was chilling. The more Earth-like planets we find, he wrote, the worse the implications. Because if the conditions for life are common, then the filter must be coming. Something stops civilizations. And we're probably not immune. Think about it. Nuclear weapons, climate change, artificial intelligence, biological warfare, nanotechnology. Any of these could end our civilization in the next century. Maybe every intelligent species develops these technologies. And maybe none of them survive what comes next. The Russian scientist Nikolai Kardashev proposed a scale for measuring the advancement of civilizations based on their energy consumption. A Type 1 civilization harnesses all the energy available on its planet. A Type 2 civilization harnesses all the energy of its star. A Type 3 civilization harnesses all the energy of its entire galaxy. We're not even Type 1 yet. We're about Type 0.7 on the Kardashev scale. If the Great Filter theory is correct, almost no civilization ever makes it to Type 1. They destroy themselves first. Dr. Seth Shostak, senior astronomer at the SETI Institute, has spent his career searching for signals from advanced civilization. After decades of silence, his outlook has become increasingly somber. I used to think we'd find something within 20 years, he said in 2021. Now the first I'm not so sure. The universe might be telling us something we don't want to hear. But there's another explanation for the silence. One that's perhaps even more disturbing than extinction. What if advanced civilizations are out there, but they're hiding? This is called the dark forest theory, popularized by Chinese science fiction author Liu Cixin, but rooted in game theory and evolutionary biology. The idea is simple and terrifying. In a universe where resources are finite and civilizations are potentially hostile, the safest strategy is to remain invisible, to never broadcast your presence, to treat space like a dark forest full of hunters. Because, here's the thing, If you announce your presence to the cosmos, you have no idea who's listening. It could be a friendly civilization eager for contact, or it could be a predator species that eliminates all potential competition. The math of the dark forest theory is brutal. Even if only a tiny fraction of civilizations are hostile, over cosmic timescales, eventually one of them will find you, and you won't know they're hostile until it's too late. So the smart civilizations, the ones that survive, learn to be quiet. They hide. They watch. They never respond to signals. Dr. David Brin, an astrophysicist and science fiction author, has written extensively about the implications. Maybe we're like children screaming in a forest, he said, and maybe we should stop. But we haven't stopped, SETI continues broadcasting. In 1974, we sent the Arecibo message toward the star cluster M13. In 2008, we beamed a Doritos commercial at a star 42 light-years away. Seriously, if the dark forest theory is correct, these broadcasts might be the most dangerous things humanity has ever done. There's another explanation that some scientists find even more unsettling. What if we're not being ignored? What if we're being watched? This is the zoo hypothesis. The idea that advanced civilizations know about us, but have chosen to observe without interference, like scientists studying animals in a nature preserve. Dr. John Ball, a radio astronomer at MIT, proposed this idea in 1973. He suggested that the universe might be governed by an unwritten rule, a kind of cosmic ethics that prohibits advanced civilizations from contacting or interfering with developing species. We might be in a protected zone, a cosmic nursery, watched but never touched. The problem with this theory is that it requires a remarkable level of coordination among all advanced civilizations. Even one rogue actor, one civilization that decided to break the rules, would shatter the silence. And over billions of years, with potentially millions of civilizations, the odds that everyone would follow the rules seem impossibly low, unless there's something enforcing those rules. Dr. Milan Cirkovic, an astronomer at the Astronomical Observatory of Belgrade, has proposed that there might be a dominant civilization, a kind of galactic superpower, that maintains the quarantine. Anyone who breaks the rules faces consequences. This would explain the silence, not because civilizations don't exist, but because they're afraid. The most disturbing explanation of all might be the simulation hypothesis. What if the universe is silent because it's not fully rendered? What if we're living in a simulation, and the programmers simply haven't bothered to create other civilizations? This sounds like science fiction, but serious scientists take it seriously. Dr. Nick Bostrom, a philosopher at Oxford University, published a paper in 2003 arguing that the probability we're living in a simulation is disturbingly high. If future civilizations have the computing power to simulate entire universes, and if they run many such simulations, then statistically, most conscious beings would exist in simulations rather than base reality. The silence of the cosmos might just be a feature of the program. An optimization. Why render billions of alien civilizations when the simulation's purpose only requires one? So where does this leave us? After 70 years of searching, we have no confirmed evidence of extraterrestrial intelligence. Not one signal, not one artifact, not one probe. The James Webb Space Telescope, launched in 2021, is now examining the atmospheres of exoplanets for biosignatures. If it finds oxygen, methane, and other gases that indicate life, it would be the first concrete evidence that we're not alone. But so far, nothing definitive. Dr. Sara Siga, a planetary scientist at MIT who leads the search for biosignatures, remains cautiously optimistic. "We're looking," she said. "We have the technology now to find signs of life if they're there. The next decade will be decisive. But here's what keeps scientists up at night. If we do find evidence of microbial life on other worlds, that's actually bad news, because it would suggest the great filter isn't behind us. The jump to life is easy. So the filter must be ahead. Something is coming. Something that stops civilizations. Something that explains the silence. Or maybe the truth is simpler and sadder. Maybe we are alone. Maybe in all the vastness of the cosmos, in all those trillions of galaxies and quadrillions of stars, we're the only ones who ever looked up and wondered. The universe created us to witness it, and then it gave us no one to talk to. Either we're alone, or we're not. Both possibilities are equally terrifying. The silence stretches on. The radio telescopes keep listening. And somewhere out there, in the cold dark between stars, something either doesn't exist, or doesn't want to be found. If you've made it this far, thank you made it this far. Thank you. This is a mystery that won't be solved by watching videos. It will be solved by looking up, by asking questions, by refusing to accept that the silence is just silence. Leave a like if this video made you think differently about the night sky. Tell us in the comments which explanation you find most disturbing, and subscribe to join us as we continue exploring the mysteries that science still can't explain. But remember, every time we send a signal into space, we're making a bet. A bet that whatever's out there, if anything is out there, is friendly. And in a universe this silent, that might be the biggest gamble humanity has ever made.